smooth slide in the shape of two arcs. So there's an arc here, an arc here. The center O of the arc FG is vertically below F as shown. The point E is R over 5 above the point F. Okay, I'm interested to see. Okay, it is an arc though, so it belongs to a circle. Okay, so sort of this red line here. See that little vertical red distance? That's R over 5. I am sure of its significance yet, but we'll figure that out. The child starts from rest at E, moves along the slide past the point F, and loses contact at H. So at H, the R value is 0. Great. Find the value of theta. Okay. Will we start off with conservation of energy? Okay. So, does it give me a radius? R. Oh, R for the full thing. Okay. And for the full thing. Okay. Yes. So what I'm going to say is that the starting point is E and the end point is H, because nothing exists after H, correct? You've gone off the slide. So can I get KE1? Does she start from rest? Plus PE1 equals KE2 plus PE2. You know the marking schemes are hard to tell what's going on sometimes. They sort of just jump in quite quickly. No, just this thing again. All right, so here's what we're going to do. KE1 is 0. PE1. How high are you in the air, guys? How high are we in the air? We're a radius plus another R over 5, aren't we? So we're actually R plus R over 5, which in my opinion is 6 over 5R. So it's mg 6R over 5. KE2, that's our speed as we exit H, yeah? So that's going to be a half mv squared. Now, I'm going to have to find out what this blue line is. Ever see that blue line? See that blue line? Is it just R cos theta? Yeah. Just R cos theta, is it? The blue line? Yeah. So mg R cos theta. Okay, we're good. We've made the first formula. That's it there. So it's going to be, get rid of the m's maybe. Sometimes you end up putting them back in though. 6gr over 5 equals a half v squared plus gr cos theta. I'll just park that there and I won't do anything else. Nothing. I don't know what direction I'm going in yet, so I'm just going to leave it there for a minute. What formula did I not use yet? I used conservation of energy, so what do I have left to use? Can anybody tell me? Centrifugal force, exactly, right? So, centrifugal force at the point H, yeah? So, H would technically have, it technically has R going up that way, doesn't it? But we all know that R is about to become 0 in a minute anyway, okay? What do we then have to do to make this formula work? We have to get the force along the radius, don't we? So what forces are taking place along the radius? Yeah, so I draw a line straight down, yeah? And that's mg. And then I resolve it parallel and perpendicular, yeah? And we should be able to figure out that's theta, isn't it? Because it's alternate. And in turn, that one's also theta. Sorry, that diagram is not the best looking right now. Don't know if that's too much better, but see the theta here? I'll just mark off my theta locations in yellow. Theta location here, theta location here, theta location there. Agreed? So what we're all saying is that that's mg cos theta then, isn't it? In this direction, and that be, so going downwards is mg sine theta. So it's r going outwards. Oh, sorry. It's yeah, I know, but if it was there, mg cos theta going inwards and r going outwards. Everybody see that? Any questions about that? So having resolved that, then we said that that's mg cos theta, and so we said is f going downwards is mg cos theta minus r, and f in turn is mv squared over r. We all set the r value turns to 0 anyway. Cancel out the m values, and now we have a value for gr cos theta. Everybody happy with phi squared equals gr cos theta? Everybody see that? Phi squared is gr cos theta. Well, that's going to be handy now, isn't it? Because look what I can do. Oh.
You forgot the pen.
Huh? What did I forget? Did I not take the m's out?
No,
There's an r over here that I'm still worried about.
That's okay, it's just when you take the m's out,
Yeah, but I'm getting the value of speed. Oh, it's actually right. Yeah, that's ms minus 2. Yeah, I need it actually. All right. So here's what I'm looking at. I'm looking at a half phi squared, and this part here is phi squared, and that's 6gr over 5. That's 3 over 2 v squared equals 6gr over 5. Multiply by 2, divide by 3, 12 over 15. 12gr over 15 equals phi squared. Yeah? And see this phi squared above? What can I change that with now? I can now change that with 12gr over 15. Gr's cancel. Cos theta equals 12 over 15. Cos theta equals 4 over 5, which is the answer in the marking scheme. And theta is 36.87 degrees. Anybody get there?
Yeah.
You ready, guys? Now, the child lands in the sandpit at point K. So, can everybody see point K? Okay. Find the speed of the child at K. Oh, lovely. This is not lovely. It's not nice at all. All right. The first thing we're going to do is we're going to zone in on how much height we have left. How much height do I have left here? What value would that be? That would be, would we all agree with r cos theta? Yeah? Okay, now, we all agree with r cos theta, okay? I'm just going to zone in on this part of the diagram. I'm going to make it a lot larger. Okay, so I'm just zoning in here. Oh man, I really wish I made that smaller. Tibex. Yes.
Since you know this velocity is 8, just treat it
You could. I think so. Perhaps, yeah. Now, V, yeah, here's the odd part. So V is going perpendicular, it's a tangent, right? So that's theta. I think we've already done this before. So if I resolve this triangle, I have to resolve this triangle parallel and like straight across and straight up, yeah? Because I have to get the velocity into I and j vector, so to speak. Okay, so here's what I'm thinking. I think I'm going to more or less go the projectiles approach in some regards, all right? So would you all agree I'm going down at V currently? Yeah? Now, what angles do I have to play with? Would you all agree that the green angle plus the blue angle has to equal what? Huh? 90. I need a different color. The green angle plus the red angle is 90. Agreed? And that means that this angle here has to be the same as the green angle then, doesn't it? Because that's a 90-degree triangle in the corner. Okay, so if they both have to add up to 90. So I've eliminated that this is theta. We can kill with that. And we know that cos theta is 4 over 5. We then know that sine theta is 3 over 5. Therefore, this is 3 over 5. Sorry, whoa. That's 4 over 5v, isn't it? Will that 4 over 5v change? Will it change value at any time? The 4 over 5v? No, because it's perpendicular to gravity. However, this 3 over 5v, what are we going to say about that? Well, gravity will influence it. Okay? Now, how far do I have to drop? I think I'm going to use linear now. Okay? So my u value is 3 over 5v, whatever that is. My v value is, we don't know, that's what we're looking for, aren't we? We're talking about the downward speed, not the horizontal speed, right? And what's my a value? Oh, it does that a lot these days. A value is gravity. S value, what's our S value? How far can it drop? R cos theta being the yellow line. And the time we do not know. Agreed? Now, I'm very careful of not getting my V's mixed up. Do you see that? Could quite easily happen, couldn't it? So what did we learn in the previous slide about V? V is all that, isn't it? For argument's sake, I'm going to store it as X. Is that okay? I'm now going to store it as X. So I'm going to store that as 3/5 X. All right? So we're going to do V squared equals U squared plus 2AS. And what we're going to get is V squared is what we're after. U squared is 9 over 25 X squared. 2AS is 2 times G R cos theta. Now we know what cos theta is, don't we? It's 4 over 5, doesn't it? So I'm going to say that's 4 over 5. Now, I have a substitute for the x squared. What can I sub the x squared with? I think I had it here. 12gr over 15. Okay, now this is not looking nice, is it? So, would somebody be so kind as to do this in the calculator? 9 over 25 multiplied by 12 over 15 plus 2 times 4 over 5. What? 236 over 125. Damn. 236 over 125 GR, yeah? Okay, that's phi squared though. So can we square root that? Actually, do you know what? Square root and change G to 9.8. Tell me what you get this time. 9.8 on the outside. What? 4.85 root R. Is that right? What?
It's just that.
What? Is that it?
I got that.
But did you? Is that 4.85 root R? Yeah. Perfect. And let me reread the question. So this wants the downward velocity, does it? Yeah, I disagree with that answer. No, the Markov scheme has that, okay? But can I explain why I disagree with it? That's only the downward speed. It's not taking into consideration the speed to the right. So should it not be a Pythagoras theorem of both?
I think I did something.
Yeah, sorry, my bad. Yeah, you guys are correct. Sorry, square root to 9.8 as well, because it will get square rooted. So what is it then? 4.3. Yeah? 4.301 root R, yeah? Now, hold that thought for a minute, alright? Now, I'm definitely thinking your method was the way to go, by the way. Your one's faster. Yeah, you did in 3 lines, did you?
No, I did.
Yeah. Now, my problem is, I still have this 4 over 5 phi, don't I? And what's phi on its own again? We know what phi squared is. What was it? 12 GR over 15. Was that what phi squared was? I think we changed it to x, by the way. I'll check it now. Yeah. That one there, see it? 12 GR over 15, yeah? And in a way, yeah, have an idea. Okay, so here's what happens. Have an idea, all right? So that's the downward speed, yeah, which is v, and the cross speed is 3 over 5 x, yeah, and I'm after the hypotenuse, right? And would you all agree that the hypotenuse would be the square root, using Pythagoras theorem, yeah? It's called the hypotenuse m for argument's sake, yeah? M would be phi squared plus 9 over 25 x squared, yeah? We have phi squared up here, don't we? What's phi squared worth? 236 over 125 GR, yeah? So it's 236 over 125 GR, yeah? Plus 9 over 25. And what did I say we had earlier? 12 GR over 15. Now here's what I want you to put into your calculator for me now, okay? Oh, we're not going like this. Over 15, yeah? Okay, I'm going to leave the GR out completely. Ignore the GR. GR doesn't matter. Can you just put the rest of that in? The 236, the 125, the 12 over 15. Dirty squared. What? Are you sure about that? Was it? 1.788. Excuse me, found it. It wasn't 3 over 5, it was 4 over 5. Replace the 9 with 16 for me. It was 4 over 5 in that direction. Surely more than that. Alright, put the G in, what you get? And did you square root 23?
No, I got
Alright,
545.
root 23 for me.
No, I got 545 and square root.
Oh, yeah, you got it. Once you root 20.
What?
Close enough. You get 4.8.
8 what?
You get 4.7.
Thank you. There we go. Somebody can use a calculator. It's 4.85 root r. Okay. Now, we've just been through a war and we finally got the correct answer. However, a quicker way of doing this would have been to do the following. Would have been to go back to the top. Back here, was it? Go back to the original. Okay. And what did you do from the original?
From part 1, we knew like this velocity at h.
So we knew it was velocity at h.
Yeah, we also know it's like over
At h, yeah.
Yeah, and then we're looking for speed at k.
We're looking for speed at k.
So potential energy plus kinetic energy.
So PE1 plus
K1.
equals PE2 plus.
K2.
Now PE2 is obviously rock bottom, isn't it?
K2 is what we're looking for.
So that's KE2 is what we're looking for, right? So that's 0. That's a half mv squared, right? PE1 is r cos theta, which is 4 over 5. So mgh, yeah? So 4 over 5 gr. Yeah? And then we already know speed, don't we? It's a half mx squared. I was calling it x squared not too long ago, wasn't it? Which is a half m 12 gr over 15. That? Yeah. Which is 6 mgr over 15. And look at how fast Albin's going to get through this as opposed to me. Did you? Ah, that's alright.
So I ended up getting 1.5 gr cos theta.
And there's an m there as well, yeah? Yeah, m's are gone. And then what happens?
1.5 gr cos theta.
So what's 4 over 15 plus 6? Sorry, 4 over 5 plus 6 over 15 is 18 over 15 gr. Is that right? 4 fifths plus 6 fifteenths. And then a half phi squared. Multiply the 2 upwards. 36 gr over 15. Okay, somebody square root that for me. Turn the g into 9.8 and square root it for me. And leave the root r to the side. And what you get? Yeah, 4.85. A lot faster than my other method.